Okay, so draft. It's really very, very dependent. So you guys all know what draft is, right? You've covered it with Pascal.
He, I know what it is.
Okay,
Pascal may have briefed over it, at least.
okay, okay.
I
So
think we
what?
all know what it is.
So, do you know why? Like, do you know what you need to take into consideration and why you have to have draft?
I think something gets like I think for the rotational molding portion, it's like you don't want to have like sharp edges, so something to make it easier to create the form.
Okay,
So it
so
won't get stuck in the mold.
Yeah.
yeah, so it doesn't get stuck in the mold. So that's not really radius related. Um, but so right, you don't want it to get stuck in the mold. So you want to make the part or the part you want to have come off as easily as you can because you've got tooling that goes down into the mold. With the red being the tooling part and the black. You don't want it to get what's called hung up. Or what happens too is it can scratch and wear, and you need to repair your tool more often, and tooling can cost $500,000. So you want to design it so that you're not having to repair it every year. Especially when you think about for some tooling and some volumes, like injection molding, you're running 1,000 parts a day, or you're running 100 part, whatever. So every time that machine is down, it's costing you money. Now, each plastic is a little bit different on what kind of tooling and what level of draft that you want. But a couple things that are dependent on your draft or the angle of the draft is that the deeper, the part, the greater the draft that is needed. So if you just have a small little part like this, you're not going to need as much draft because the tool doesn't have to travel as far. So the deeper the draw, the greater the draft needs to be. Now, that can really affect the design or the style of what your product looks like. So even when you're doing concept sketches or the initial 3D models, you always want to have an understanding of what your draft is. There is nothing more that I hate than industrial designers who do all these sketches and should know better, 10 years into their job, 5 years, and they show these models, they show these renderings as final designs, and they don't take any draft into consideration, because if you have to do 10-degree draft on something, let's say, so I show my model, I show my model and my sketch has this, beautiful form, like that. We'll say that's a beautiful form. Well, the reality is, if I have to have that much more draft on there and I have to have something like that comes out like that, well, that's going to look way different. So in the end, someone sits there and says, well, why doesn't this look like what the ID people showed us? And the engineers have to explain, well, they didn't design it for manufacturing. So it's not that during our initial rough sketches we have to do that. Now, a few other things that come into factor when I talk about material. And part of it too is it's not only to allow the tool to get off easier, but it's how the tool will interact with the part. So more often than not, what happens is tooling will scrape as it's coming out of the machine, or as the part's coming off. Because you need to have it extremely tight. Now, what that scraping does is it causes marring. Now, it's not so bad if it's causing some marring on the inside of the part, but when you have a highly polished outside and you get scraping, that becomes an issue. Especially if you're doing clear acrylic pieces. And sometimes what happens is that last little part up in here where the tool's coming off, right in this area here, since that's the last little piece, and there's usually what's called a little flashing. And what flashing is as the plastic is poured in, you'll sometimes get this little bit of edge of plastic that seeps out. What happens is this part then all of a sudden gets scrapes and you notice it. Now, not always a big deal, but where it becomes a bigger deal is when you have a texture. So if you have a beautiful texture on your part, and we're going to go, so nice texture. What happens is, if you don't have enough draft, is when it comes off the tool, even though that's how you design it with the texture, what happens is it scrapes it, and eventually it wears it off to be smooth. So now all of a sudden your part has a whole section that doesn't have texture on it anymore. Are you guys familiar with Mold Tech?
That'd be a no.
Okay.
It's like rubberized, isn't it?
No. So Mold Tech is pretty much a standard in the industry. And what they do is they make all the textures. Like when someone in Asia or America or whatever, when you are saying, hey, I want this texture on my part, they're the ones that you buy the texture from. And they do the EDM machining into the part. They have websites, and also you can download the Mold Tech texture pack for Keyshot. But the cool thing about Mold Tech is if you've got texture square, A72, it will literally tell you on that what your draft needs to be. Because with the textures, you got some that is really small and some that's really big. The bigger the texture, the greater the draft. Is this information of value?
Yes.
Okay. Now, it's not to say that you can't do parts with overhangs. You just have to maybe have different types of draft areas. So if I'm going to do a part that comes up like this, comes out like this, comes here, and we're going to say it does this, and then that. So here, this part, or this part of the tool, very easy. Nice, clean, simple, no big issue there. It's going to come off, go straight up. Now what happens is, here you've got an undercut. And what that means is I can't simply make this tool. And the reason for that is if I pull it down this way, it gets hung up here. Sometimes, depending on the part, depending on how much of an undercut it is, and this is where you always talk with your manufacturer, because all manufacturers are different. One may say, yeah, we can do it. Another may say, that's not what we recommend. If you do that, we're not going to guarantee you the parts are nice. But for some parts, if it's really flexible, you could pull it off like that, or you could increase how much force is to push it out. But what you can do is you can do what's called a slide. So here, let's just erase that. The bottom tool comes down to here, which now can pull down perfectly clean. And then what happens is it's called a slide for that exact reason. There's a part that comes in here that is a tool. And literally what it does is it pulls in and out. So it goes in while the plastic's being poured. Oops, let's do that. It goes in while the plastic's being poured, and then when the part needs to come out, this section slides out. Now the reason I tell you that is because this is where things get a little bit more complicated within doing the 3D model. Because now what happens is you have to be aware that you need to have this face with an angle. So since it's pulling out, and let me just change my brush here. Since it's pulling out, you want to have this taper so that the part pulls out smoothly. Make sense? Oh, whoops, I did that the wrong way.
I was just gonna say.
Yep, I realized that as I said you wanted to pull out smoothly, I'm looking at it, I'm like, that's not gonna pull out right.
You want to make sure that it snaps on the way out.
Yes,
So
yeah.
I'm guessing that the difference between that extra slide is manufacturing costs.
Correct. Now, when I started my career, I always got told I couldn't do slides, I couldn't do lifters, because we manufactured in North America, and adding a slide would cost sometimes $20,000. Well, so inexpensive when we moved to China, that exact same slide, and this is why North American manufacturers lost out. Chinese manufacturers would say, yeah, we can do that, $2,000. So it really opened up the possibilities for what designers could do. But, again, can the product afford that? You know, because when you do tooling, you've got to, let's say we need to make, right off the bat, we want to make our money back. Well, that means we've got to make, let's say we spend $100,000 on tooling, we've got to make at least $100,000 to break even. Or whatever our profits are, we have to subtract $100,000. So every time you make a more complex tooling, the more you're cutting into your profit. Or what happens then is the more you may need to sell your product for, because you're not going to necessarily guarantee increased volumes. Okay. Now, what was the next thing I was going to talk about here quickly? So draft for, yes. So now let's talk about draft and the way it flows a little bit. So if I have, so I've got a box, let's say, and in the middle, I want to have a rib because I need structural support in there. So here's a couple things that happen. How many of you have ever looked at a product, usually something plastic with gloss, and you see what looks to be like a dent in it or like a long line that it kind of, you know, it's not smooth. It looks like it's caved in a little. No one?
A parting line for plastic?
No, not a parting line.
Would you have an example of that?
Yeah. Shoot, what do I want to call it?
That's the schmoo line.
Yeah.
A dent? It's really low.
Oh, I know what you mean. It's like a little dimple.
Yeah. Of course, that's not going to... You never see it in the renderings because people brush it out.
It's a defect or it's put in there on purpose?
No, it's not put in there on purpose.
Okay.
I'll find an image and I'll send it to you guys after class so you can kind of see it.
Okay.
But basically what happens is, and this is what it kind of looks like. So let's say I've got this part. And it's hollow. But in here, I've got a rib. So what happens is, when you get the material, what you'll see is this surface will kind of come, and then you'll just see like a little, really, that's exaggerated, but you'll just see a little bit of a wobble in there the entire way down. So what happens is,
Oh yeah, I know what you're talking about.
yeah, so what that is it's material flow. So a rule of thumb is that your ribs should be no less than 1/3 thickness of your outside wall. So if your outside wall is let's do this, 0.15. Oh, no, whoops, sorry. 2/3. So if your outside wall thickness is 0.15, then your inside wall should be 10. And I'm talking millimeters here. Oh no, we're talking inches. And what that does is it allows the plastic to come through. Because you're going to have, like, the plastic has to enter somewhere. So it's got what's called a gate. So let's assume the gate is here and the plastic is being pushed in here. What happens is the plastic flows really nice. It's going to go up there and it's going to keep getting pushed up. And then it comes up like that, closes off really nice. Now, what happens is, so that's a good example. But when you're working for products that have tight cost margins, usually housewares, that's plastic. I want to pull a penny out of that part. Penny doesn't sound like much, but if you're running a part and you pull a penny out and you're running 500 a day, 5 days a week for 6 months or for a year, that adds up. But what happens then, and you kind of saw what was happening there when I kind of scrolled around a little bit. It comes to do with pressure. The pressure is how much plastic goes through and how well it can be pushed up into things. Now, the thinner it is, the more pressure it's going to take to push up into that rib. Also keeping in mind that your rib has to have whatever draft you need. So if you really thin that rib up here, it gets wafer thin up at the top because of the draft. But what happens, let's get back to a green color, is that as the plastic is pushed down, as the plastic goes through, it takes more force, so it keeps going this way, but what it does is it comes in here first, and then it tries to go up there, and then it keeps flowing like that. And you've only got so much time before the part cools. So if it cools and the plastic hasn't gone all the way through because of cycle times, you end up with your part looking exactly like that. So you end up with this ripple. That's why in an ideal situation, ideally if someone's asking you, hey, what do you want to do? You want to try to push and say, look, that extra little money is going to help this product to look good and have good quality. You know what? Hold on. Let me see. Sunbeam coffee maker sink lines. Let's see. I guess they got better. Because the term just came to me that it's... Oh, come on. Come on, I just want to see a real product that has an example in 3D. Okay. Notice how I can't let things go sometimes? We'll come back to it. We'll come back to it. Okay.
I gotta think I've seen those in like Legos before.
Yeah, yeah. Usually it's where things are thin walls. And sometimes you'll even see it in 3D printing. But, so, like I say, I'll find an image later. Okay, so, we talked about the depth of the draw affects the draft. The plastic that you're using affects the draft, i.e. if it's a really, really hard plastic, there's not going to be any give or bend, so you've got to make sure there's more draft. If it's like an ABS part, well, there can be a little more give on that part. It also is dependent on the manufacturing process. So with injection molding, if it's a small part, you can sometimes get away with 1/2 degree. If it's rotational molding, the rule of thumb is nothing less than 1 degree, and that's if you have a completely smooth surface. If you start adding texture on there, and depending on how tall it is, that draft has to go up. That's why it's always great to talk with the manufacturer or talk with the engineer, or not the manufacturer, but whoever's doing the tooling, because they'll give you a good, honest answer, knowing that they're always going to err on the side of larger draft because it makes it safer for them. So, with that said, let us go into SolidWorks, and we are going to use the cooler as an example. Now, on here, hold on. There we go. So on here you can see that there's no draft, and all that means is that when the tooling is going to come down this way, there may be scraping. It's not going to hang up because there's no undercuts, but there could be scraping, and it may require a little bit more force to push it off the tool, which then slows down the cycle time, or it may be harder to get out of the tool in the case of rotational molding, which is much more of a hand kind of process for larger parts, lower volumes. If you have draft on there, then that's going to get worn and scraped away very quickly and easily. Same as the top. Now, this is going to be a big thing too. So draft is actually really simple for a part like this, and that is simply when you extrude it, if you know what the draft, or if you know that you're going to need draft and you want to do it, it's as simple as clicking on the left on this button here, which is draft, and you got 2 options. So you can increase the draft, and it goes in the direction of your extrude. So you can increase it, and notice how it's going outward, or you can go inwards. Now, let me just exit out of that. We know that this part, or we can assume that this part is going to be molded in the sense that how can I show this? This tool here is going to be coming down this way, in this direction. Does everybody get that and understand why?
I mean, I do.
Okay.
I don't really, but
Okay, so where did you go?
What are you looking for?
Nothing. My symmetry's off the screen for some reason. So you've got this part. And then it comes this way, and then there's the interior. We'll only draw half. So what we know is that there's going to be two parts that come out, or two tools. We're going to have the top and the bottom that are going to build the cavity. So this is the internal. So we're going to have two parts coming in two different directions for this part, and for almost all parts. We're going to have this tool here. Now, this one has to come up this way. And then we're going to have the tool down here. And the reason you can see I've got this overhang here is because it's got to connect and close off somehow. I don't need that radius down there because that doesn't do anything. This tool is going to have to go in this direction. Is this making sense?
oh, yeah, that makes sense.
Okay. So, with that said, if this tool is going down this way, we need to have draft on this wall in relationship to here. Let's do this. So what that means is we have this part here. And we're going to want to have some draft on there to make this easier to come off. So what that means then is that our tooling part is going to have that draft. That's what creates the draft. Same as up here. We have to have that draft there. So what that does is it helps to ensure that as that part comes down, there's that draft there and help make it smooth. So that's kind of how, when you look at your part, you know that that's what's going to happen. Now, if you have a part that has a parting line, so that was nice and perfect because it closes off here perfectly. If, let's say I have a part that looks like that. And this is the way I need to have a tool. So you're going to have a part line here where the tool comes together. But you can't make this. And let me use this as an example because I had a design manager after I just started at the company get in a yelling match with the engineer over draft, and it was a really awkward yelling match. Kind of made me regret it. He quit 2 weeks later. But if you've got a circle, it can't be perfect like that because there's zero draft there. So what you have to do is the circle's not really a circle anymore, because you need to have it start at a certain draft. Now, depending on how much you can push it, you know, because let's say this is it, there's got to be that little break in there. Okay, so now that we've got this, what we can do is at the very, very beginning, because sometimes you can add draft to your model at the beginning or you can add it at the end. When it comes to bosses and ribs, that's like one of the last things I do, just because it's a final detail that's not necessarily needs to be shown at all times. So you can come back in, we'll edit this. So we're going to say we know that it's rotational molded. We know that we've got a texture on there. We know that it is 2 feet deep. I've done my Google research, and Google tells me it needs to be 2.5 millimeters. So, and you're going to see how this changes things. So I can click on the draft button. I'm going to go, so outward, inward, depending on your part. We know that this is outward based on what we just talked about. And we're going to say, we're not going to say, it's 2.5. So you can kind of see, whoops, you can kind of see how that changes the look of the model from there to 2.5. And you can even see half a degree can make a big difference. You know, or 1 degree can make a big difference. That's why you always got to work with your manufacturers, you always got to work with the engineers to see what you can do, or you need to make sure that in your design, that styling is going to work. This is where it becomes very valuable to learn from engineers, because if you hand them your design and it looks like this, and all of a sudden they make the prototype and it looks like that, you're going to be in for a surprise because it may not fit with the vision. And if you knew, you may have been able to done something with your design to make it look better or to accommodate. Because now you can kind of see in this here, let me just go back here. See how these went perfectly straight up? I mean, it looks nice because everything is nice and consistent. But now, you know, I come back, or the engineer comes back, and he has to add draft. And if anybody has told you that engineers are going to try to destroy your designs and you have to fight with engineers to make your designs look good, they're idiots. I know a lot of teachers who do that and a lot of designers who say that. It's ridiculous. But we update that. You can see now that these lines are no longer parallel because of the form. You may be fine with that. You may not have an issue with that. But if you had modeled that in, you may have done something different in your modeling, in your concept. Now, here's where I'm talking about, where before, and let me just go back, and we will turn off draft here perfectly. So you can kind of see here, you've got that perfect straight line there where it goes up and it mates beautifully. So if we now come in and we go, okay, well, we need to put 1 degree, or we're going to say 1.5. 1.5 degree here. It starts affecting the look. Did that go in? Okay, so not very noticeable. You know, doesn't look bad. But, let me just see if I can find where that is. Okay. What's going to happen now is this face, or up to this point, you're going to need to have draft. Let me just do this here. And this is how you always tell, or when I'm doing my surface modeling, let's say it's a spline that you want to get, this is how I know how I have to do it. So I'm going to draw a line here. I'm going to then draw a line straight up. And we're going to place it right here. Well, I know that it's got to be, where are we here? What did I say, 1.5? Come on. Oh, come on. Okay. What am I doing here? 90, 88.5. So there, I know how it's going to have to change. Now, if I'm doing splines, I'm even more cautious. Because if I'm drawing a spline from a certain point, and let's say the point is right here, and I'm going to draw my spline, and I'm going to go like this, and I want the spline to look like that, and I do that, I'm going to check my curvature, does exactly what I want. Oh, wait, it's not tangent, okay, so let's just come in here, we'll make that tangent. Okay, not what I want, but this looks good. Well, here's the problem now. I have to then come in here oh. Come on. I hate this. Stop doing that to me. Well, now you can see that with that draft, I've got a little bit of an overhang. And what that means, oops, let me select that and that. What that means is there's going to be scraping there, or it's going to be harder to come off the part. So the engineer's just going to modify it, and he may rebuild the surface. He's going to do what he needs to do to make it a valid part. Here's what you can do, though, is let me delete that. You can either eyeball it and just say, well, this is what it needs to be. But now you can kind of see I'm starting to get inflections, which is part of the reason why I would never use that to begin with. But, oh, it's so hard. So there's a tiny little inflection there, but that's just going to be the nature of the game. What you can do, so where this triangle determines the angle, wait, no. Why is it not letting me? Oh. Huh. Okay, I'll have to look into that. Because you should be able to dimension that angle. But either way, I can adjust it so that I get the point, 1.5, and I check to make sure so that I know when I go and do my part, that's a surface part, I've got that in there, because it's not as easy to create draft on a surface as it is on a planar face. Okay, so let's exit out of there. Now what we want to do is we're going to come on here and we're going to add the draft there. And since this has a shorter draw, it's not as tall, we're going to assume that we could get away with less of a draft. And we're going to go with, the texture, everything is normal, so we'll just go with 1 degree. And the draft had to go inward, which I didn't do, it went outward. I can never remember what direction I'm going in, so what I do is before I choose it, oh. Okay, so since you made the model from up here, ooh, okay. So here's the thing about modeling. Ideally, what you should have done is you should have built the part down on this line, and I'll show you why here in a second. Because what you need to do now, in order to get this drafted, you would need to take this profile that the system has just frozen up on me. Oh. Okay. Oh, come on. There we go. So, let me just roll back all the way to here. So, since you built the part up here, what you have to do now, in order to get the draft on this the way you want it, you would need to come back and figure out how much you offset this in and then draft it down. Does that make sense?
Could
Yeah, I know what you mean.
Yeah.
you could just delete that extrude and convert entities down
Yep.
and rebuild it from the bottom, couldn't you?
Yeah, you can. You want to plan ahead because that would be a fix, and you're going to make your model more complicated. But if you
Right.
have that's something else. Like, you know, when you're planning out, and we haven't really got into it, but when we're planning out, okay, hey, I want to build a product. It looks like this, and I'm going to have a lid. And you know the lid is going to do that. Is going to do that. So I want to. You know what? I'm going to have draft on this. So let me build this part going in that direction, because then I can draft it in or out. And it's not so bad here because I could draw it down here and draft it up whatever way. But because I know I'm going to want to draft this one inward, let me start here, because then that's easier for me to draft it like that than it is to, you know, if I build it here and I try to draft it, you're not going to get that match. So then what you need to do is you almost need to figure out, okay, how much inboard do I go? All that. Okay. I want to show you now how to do a rib using the actual rib feature. I'm going to go new. Now it's been a while since I've used rib features, because I don't do production parts anymore. So we're just going to go to top plane. We'll do a sketch. Scrap a square in there. Exit out. Let's go left. Oh, 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 oh. We're going to go there. We're going to draft it. So you can see that for this, it's being drafted outwards. So we're going to shell that. No, not sketch. Okay, so we've got our box. Now, this is where you have to think about how you're doing it and what way your part is going to go and is going to be drafted. So So again, we're going to have, I'm just going to ghost it in here, a rib like this. Which, not a problem, because like we said, we've got our draft here. That's a simple one. Now, here becomes the complicated thing. So, we're going to have our tool here. That comes in. And let's assume we don't have any rib there. Now, that's not a problem. It's just going to come in and out really nice and simple. But with the rib here, you now need to have draft. So here, you had the draft going out this way. Well, here, you have to look at it as two separate parts or tools that go in to pull out. So if this is pulling out this way, we're doing great here because you've got that angle. But now this rib needs to be angled this way. So what you're going to have to do is angle it outward. That's really hard. Now the trick is, that's really exaggerated. You wouldn't have a rib that much. Let's so let's assume that's, let's say that's the 1 degree. And for the most part, you guys don't need to worry about these unless you really want to show the part. Like, for example, I may do a 3D prototype for someone, but it's only going to be a prototype. So if I'm 3D printing it, I may put the ribs in there for structural strength, but I don't worry about putting draft on my ribs. I'll put the draft on the outside if that's noticeable, but I don't do drafts on the rib because I'm not pulling a tool off of it. But what that means now is this rib is the opposite direction of there, so that you can pull your tooling off. And again, that needs to be the minimum draft. You can get away with less draft if your rib is only so high. So, with that said, we go back to SolidWorks. We've got our draft on the inside. We've got the draft on the outside. What we're going to want to do now is use the rib feature. Let's see if I remember how to do this. So there's a couple different things you can do. You can make it really simple, where we're going to just come in and we're going to draw a line. I'm going to do another one here. So let's say I just want a rib going all the way across. Just going to draw a rectangle. Oh, sorry. I want it to go all the way across, so I actually have to overbuild it. And then I'm going to extrude it up. So there's my first rib, but I have no draft on it. I could have extruded it with the draft. We'll just do it exaggerated. So that it's there. You can see the drafts on both sides. Now you want to be careful, because if they say, well, your wall thickness has to be, you know, the same thickness as everything else, what happens then is if you're too thin, it becomes really thin up here. So, but let's go back here, undo this. We'll come in, use the draft tool. Select a plane, a planar face, or an edge on which to sketch the feature. Oh wait, hold on, no. I want to use this tool here. So this is a separate tool. It's the exact same as the feature that you were using inside, but you can do a little bit more. So I'm going to click on it. I'm going to say I want, you know what, we're just going to go with a 4 degree so we can see it clearly. It's then going to ask for the face, or the faces. So we're going to say this face. Oh, no. I'm going to get this wrong. Hold on. So it wants the direction of the pull. So we're going to go with this face. Basically, you know, what way is the tool pulling? So the tool is pulling off of this surface, and you can only pull off of that surface vertically, not horizontally. So now it's asking for what faces. So we're going to do that face there. We'll do that face there. And, oh, I haven't seen that one yet. Oh, neat. Okay, cool. I'll show you that. We're going to hit apply. And I don't know if you guys saw it, but did you see that taper out? So we'll go to 0. We're going to do the draft. And we're going to do auto paint here too. So again, the face that it's going to be pulled in. And right now, you can see with 4 degrees, the outside is good, the inside is good, that's less than 5. We'll do this face, and let me just crank that up even more so we see it. And it goes outwards. Now, what you can do is you can change the direction. So right now, this is assuming that this face is pulling up this way, so that's the direction the tool's pulling up. If it's going down, you switch the face. Oh, and it's too much because I think it would end up being 0 down there. Oh, nope. There. Hold on. Let me get out of here. Anyways, it reverses the face. Now, what you can also do is you can adjust one of these faces. So there are times where you might need, on the inside of this, the draft on this face may need to be greater than the one on this face here. What you can do is with that tool, you can select specific ones. So let us go with, again, the direction of the pull, since this is going up and down. We want to select this face. We're going to go with the pull direction down because that's what this face is doing. We'll select this face. Now, if I'm doing this right, let's turn off auto paint. And for some reason, they don't have preview on this, which I think is stupid. It should just do that singular face. Did you guys see that? I'll assume that's a yes.
Yeah. Hey, another question, Chavez. So Pascal was saying like the minimum wall thickness. What does that really have to be? Because he said like 2.5 to 3 centimeters, but I asked John today, and he's like, no, you can get away with like a ½ inch. So I don't know.
So wall thickness is, again, it's dependent on so much. The process that you're using. You know, the bigger the wall thickness, the more expensive because you're using more plastic. The more plastic that you're using in the part, the longer it takes for the part to cool on the tooling. And if you push a part off the tool too quick while it's still hot, think about grabbing your 3D print off your printer and it's still hot. You're going to deform that part. And if cycle time is very important, i.e. we've got to have 2 parts per 5 seconds, you've got to accommodate for that. But really, a large part of material thickness comes down to how strong does this need to be. along with how many ribs do you need, how much thickness. If I am designing a cup that I am drinking out of, I don't need to have it all that strong. I don't want it to be a plastic, like one of those squish. I don't want it to be a solo cup, because I want more rigidity than that. But I'm not going to stand on the cup, so I don't need as much plastic as that. And you have to determine what that is going to be. So for your cooler, it needs to be, if you're going with durable and rugged, it might need to be a little bit on the thicker side. Think about what Yeti has done. I mean, you can drive a semi over those. Someone could argue, oh, it's a cooler, it's not going to take much abuse. Well, think about this. How many people sit on their coolers? How many people stand on their coolers? You're going to want it to be a little bit stronger. So, injection molding, you can get down to a 0.05 wall thickness if you want. Most products go with 0.09. Higher quality products get up to 0.125, 0.15, and that's really the feel of the product too. You pick up a product and it just feels flimsy, it feels cheap, it feels like you see those glossy dips in that. That's because they saved money on their plastic. You pick up a nicer, higher end product, so like you buy the $10 coffee maker versus the 30. The 30 feels a little heavier, the plastic feels a little harder. That's how you're going to determine it. So I can't necessarily tell you what the thickness for rotational molding needs to be because I don't do too much of that. But if you are doing rotational molding and it's going to be injection filled or foam filled with a foam core, then you can get away with something a little thinner. So I'm not really answering your question. I'm telling you it depends. Is this...
Okay, yeah, I understand.
Yeah. So now here's the thing. And we did this in school constantly, and our teachers constantly encouraged us. Because you've got a power as students. Call up, find a rotational molder in Wisconsin. Oh, no. One of the teachers, former teacher here, don't tell him I sent you, though. Don't tell him I sent you. Shoot, what's his name? Okay, hold on. So, call up a manufacturer, call up a prototype shop, call up any of them, and just say, hey, I'm a student, I'm working on a project, I'm doing a cooler, it's rotational molding. Do you have 5 minutes to just help me understand what some of the tooling restrictions are? Or send them an email. I can't remember his name, but one of the designer that works here used to teach CAD for you guys. I think Evelina knows who he is.
Is it Julian?
That's it. Yeah, Julian Hurley. So he's their design engineer. So here's a great chance. Don't all bombard them, but one of you make a connection on LinkedIn. Do the note. Say, hey, I'm a MyAd student. I know you used to teach 3D modeling here. I know you work at a prototype shop. Could you answer a question about what kind of draft and wall thickness I would need if I was designing a beer cooler or a cooler?
What?
Go ahead.
What prototype shop? Like, what shop does he work at?
It's called IPPD. which is, shoot, I don't remember what IPPD stands for anymore. Innovative Prototyping and Product Development. Ask, Mark Gondek is the owner. Ask if he'd be willing to have one of your ID. Evelina, are you IDSA?
Yeah, I'm the senior rep.
Oh, awesome. Whoever's the rep, reach out to them. Oh, never mind. It's COVID life. Reach out to him. Ask him if he'd be willing to do a Zoom meeting with you guys and kind of do a 101 on prototyping.
Yeah, let's do that.
And for him, say, Chevis Watkinson said we should reach out to you. That way, if he curses and swears, it's at me. I haven't talked to him for about 10 years, so that's an awesome way to touch base with him again.
Gotcha.
Yeah, so that's a big thing. When you guys are working on these things, reach out to the specialist. Post it on LinkedIn. I guarantee you, watch this. To my tooling connections, I am working on a cooler design for camping. What type of draft and wall thickness should I consider? Now let's make sure I've got spelling right here. To my tooling connections, I am working on a cooler design for camping. What type of draft and wall thickness should I be considering for rotational molding, right?
Yep.
Okay. Now I guarantee you I'm going to get IMs and I'm going to get people who are saying, hey, we can mold it for you. But this is a great learning tool. This is why some people say, well, why would you ever connect with an Asian tooler? Because you don't know them, you haven't met with them. Well, I do prototyping. If I ever have a customer that wants limited runs, I use them. Or if I have a question like this, if I don't have a resource, I can reach out to them. So let's just post that and we'll see what I get and when I get it. Okay. I think I've talked enough about ribs. Probably longer than I thought. Any questions?
I actually have a question, but it's not related to ribbing.
Okay, so let's wait. Any questions related to ribbing? No? All yours. Go ahead.
Okay. I was wondering if you could show us in SolidWorks, like, if you were to make like a model of like a water bottle or like some sort of like something to like hold liquid, right?
Yep.
How could you measure like the volume of it? Like if you make like a house part.
Yeah. Okay. Come on, Chevy. Okay, so for this, I'm not going to shell it. I'm just going to create my draft right off the bat. Or not my draft. I'm going to create a revolve that uses offsets. So we're going to come down. Ooh, not that big. First, we're going to reverse. And then we're going to go 1. And we'll do that. And Actually, I don't want to offset that. Whatever, we'll do that. So there we go. We'll delete that line. We will extend that to there. Oh, that's not going to do it, so we're just going to drag it. No. Okay, so I'm going to cheat here. Oh, hold on 1 second. I'm going to stop the